Good morning everyone. Here my name is Syed Mohammad Saad. I present before you to represent my paper under the topic Steps for Realization and Performance Evaluation of Selected MPPT Technique. I am sure that you everyone be aware about MPPT techniques because this is the most researched topic in the field of non-conventional energy resources. As the presentation proceeds, we will talk about the following things: introduction, state flow implementation and its system modeling, result and comparative analysis, and finally we will lead to the conclusion. As we all know, with the increasing population and advancement in the technology, the demand of electricity is increasing day by day, and this is drastically increased in last 2 decades. To cope up this demand, we will need other resources because conventional energy resources are depleting day by day, and there are many problems arises in extracting energies from these resources. From the non-conventional energy resources, solar energy emerges as a promising alternative source of energy. But there are some issues with the solar energy to convert the solar energy to the electrical energy. One of the foremost issue that we faces in utilizing the solar energy is the lower efficiency of solar panels because of its varying operating point with varying atmospheric condition. One of the solution that we found generally for this problem is implementing MPPT, maximum power point trackers. Here in our paper we try to reduce the drawbacks of maximum power point tracking techniques by implementing with help of state flow. State flow is a newly developed block in the MATLAB. There are many blocks in the MATLAB, but they are quite complex. State flow has many advantages or edges over other blocks, as it easier to see what is happening inside the machine. Very easy to find the error in the by the programmer. The complexity is reduced, and the results that are obtained by the state flow implementation are quite accurate and precise. Here we first talk about maximum power point tracker. With the help of DC converters, here we use buck boost converter. We also can use other converters as well. The MPPT tracker changes the duty cycle of buck boost converter on changing the load or changing the atmospheric conditions to operate the system at maximum power point. As I showed you, this is the maximum power point of these 3 curves. It will vary according to the irradiance or other atmospheric changes. To work at MPP, we required a tracking system to track it well. As we know, there are many processes or through many controller a Simulink will work. But in case of state flow based models, all these work will occur in a single block. For example, initialization of system, then the calculation, and then operation that occurs. On the basis of operation, whether it decide whether to decrease the duty cycle or increase the duty cycle, all these functioning will occur in a single block, which reduces the simulation time as well as the complexity of the system. And through the state flow blocks, we can easily visualize what is happening inside the machine. As you can see in these 5 pictures, you can this is a from initializing to the end, and on the basis of end results, whether we have to increase or decrease the duty cycle, all these work will occur in a single block. Mainly 4 MPPT conventional techniques are known: perturb and observe, incremental conductance, fractional open circuit voltage, and fractional short circuit current. Out of which we implemented these 3 techniques in our state flow based model. We have used the PV model to implement our techniques. The specification of the PV model used by us in the Simulink is given below in this table. Now first we talk about perturb and observe technique. This is the most conventional technique and most reliable technique to be used to track the maximum power point. In this method, we first increase the voltage. On the basis of increase the voltage, we will see the change in power, and on the base of sign of change in power, we will decide whether we have to shift right or left to find the maximum power point. However, there are many drawbacks of this techniques. The two are the major drawbacks is its fluctuation. Its fluctuation around the maximum power point is quite large, due to which it never reaches to the exact maximum power point. It will fluctuate near to it, and its tracking time is quite large. Because of this, sometimes it gives false result or the false tracking. Here on the state flow based technique, these two drawbacks has been removed. You can see in this picture the oscillation that occurs in the state flow based models are quite low, due to which it will reach the maximum power point easily. Now we will talk about another technique which is implemented in state flow based model, fractional open circuit technique. This is another conventional technique and has disadvantages as well, but its tracking time is low in comparison to perturb and observe. With the use of state flow model, we have decreased the fluctuation in fractional open circuit voltage and also increased the transient stability of the system. Fractional short circuit current. We also implemented this technique in the state flow. With the help of state flow, we will decrease the fluctuation in this model, as well as the complexity is reduced and transient stability is increased. This is the fastest tracking method we know up till now. Now we will talk about the different results we obtained by the implemented techniques. Here you can easily see that perturb and observe has the highest efficiency among all the techniques, but the tracking time of this is quite large. But in case of FSCC, the tracking time is low, but its efficiency is also low, due to which most of the time we believe in the result which we obtained through perturb and observe. In this bar graph, you can easily visualize the difference between the techniques. For example, perturb and observe has the highest efficiency in comparison to FOCV and FSCC, because FOCV and FSCC sometimes give false result because they are dependent on a constant, and it is basically a theoretical concept. When we work practically, there are some differences between the practical PV model and the theoretical model. Here, but the tracking time by perturb and observe is quite large, due to which sometime when the changing atmospheric condition is very fast, the perturb and observe will track a false MPP. But in case of FOCV and FSCC, tracking time is low, but its efficiency is also low. Now here we talk about the results of our simulation work and compare it with the existing conventional techniques. Here we found some appreciating results. For example, in perturb and observe, the settling time is 0.06 for conventional technique, where in for the SFB technique it is lower to 0.45, and you can also see that fluctuation is reduced by a great amount. About 14.2% fluctuation has been decreased in comparison to the conventional. In the similar fashion, you can say you can see that for fractional open circuit voltage, settling time is also reduced in case of state flow based model. Its fluctuation also decreases. But in the FSCC, the time settling time of state flow based model is increased, because fractional short circuit current complexity in conventional method is very less, wherein its complexity is increased in case of a state flow based model. You can visualize the results with help of bar graph as well, that perturb and observe settling time is decreased by great amount in case of the state flow based model. And the settling time is the foremost thing. Settling time also shows that the transient stability of the system is also increased, because the overshoot and the undershoot in case of the state flow based techniques is quite less in comparison to the conventional one. A similar thing happen in the fractional open circuit voltage. Here are the conclusion which we have drawn from our research work, that among the implemented techniques, the fastest technique is fractional short circuit current with the tracking time of 0.023 second. And also the tracking time of fractional short circuit current and fractional open circuit voltage is less in comparison to perturbed observed, because the sensing parameters of FSCC and FOCV is single, where the sensing element of the perturbed observed, we have to sense the two parameters, hence its tracking time is increased, but the reliability of perturbed observed technique is quite large in comparison to FSCC and FOCV. The biggest problem that we face in case of the perturbed observed in conventional technique is of fluctuation. It never reached exact point of MPP. It always fluctuates near the MPP point, where this fluctuation has been reduced with a tremendous amount in case of the state flow based model. And this same thing will occurred in case of fractional open circuit voltage. Its fluctuation are also reduced. Above these two benefits, there are other several benefits of state flow based model, is that it improved the transient efficiency and also increased the response time of the system. The system's response time is become faster, and we can easily simulate our model and can easily realize what is happening in the tracking. Here are the references through which we take in our research work. Thank you for listening my presentation so patiently. Hope with help of my presentation I am able to make a space in your hearts.